Hi everyone, welcome to my Sudoku solver project. Today I will walk you through how I built this solver with a special focus on the unique bitwise operation that power the solving algorithm. First let's have a quick look at the user interface. Simple, clean and functional. At the top we have a logo followed by a 9 by 9 Sudoku grid and three key buttons which are get puzzle, solve puzzle and reset puzzle. This UI allows us to fetch a random Sudoku puzzle, solve it instantly and reset for another try. Now behind the scenes, the project consists of three files. HTML for the structure, CSS for the styling grid, and buttons, and the JavaScript for the logic. The focus on this video is on the JavaScript file where all the logic for solving the Sudoku puzzle resides. Now let's talk about the core part of the project, solving the Sudoku using bitwise operations. This approach is extremely efficient and helps us keep track of which numbers can be placed in which positions. We maintain three bit masks, namely taken row, taken column, and taken grid. Each of these is used to represent which numbers are already placed in the rows, columns, and 3 by 3 grids, respectively. Think of each number as a bit in a binary number. For example, if the number 3 is placed in a row, we set the third bit of that row's bit mask to 1. This is done using the XOR operation, which sets or clears bits. Similarly, columns and grids are tracked in the same way using bit manipulation. Now, let's break down how this solver works. The function recurrence is responsible for filling the Sudoku grid. We use backtracking to explore different possible numbers in each cell, but instead of checking all the numbers one by one, we use bitmarks to eliminate choices efficiently. Here is how. We get the possible choices for each cell by looking at the taken row, taken column, and taken grid bitmasks. We or them together to see which numbers are already used. Then we invert the results to get the available choices. This gives us bitmarks of the numbers that can legally be placed in that cell. Now look into the getChoices function. In the getChoices function, we combine the bitmasks to see which bits are taken in that specific row, column, and grid. By performing a bitwise AND operation with bitmask of possible numbers, we can quickly find out which numbers are available. This step drastically reduces the number of possibilities to check. Now coming to the make move function. Once we know the available choices, we attempt to place each number by updating the bit mask using the make move function. If placing the number leads to a valid solution, the algorithm continues solving the next cell. If not, it backtracks by removing the number, resetting the bit mask using the revert move function, and tries the next possible number. This backtracking mechanism ensures that the solver explores all valid configurations until it either solves the puzzle or concludes that two solutions exist. With the bitwise operations, the solver doesn't need to iterate over all possibilities explicitly. Instead, it just checks the valid options provided by the bit mask, making the process much faster. Let's see it in action now. I will click Get Puzzle to fetch a random board, then I will press Solve Puzzle to watch the algorithm solve the Sudoku in real time using bitwise operation. As you can see it, I click on the Get Puzzle button and here is a random Sudoku puzzle that pops up. Now I will be clicking the Solve Puzzle button, which will be then solving this Sudoku solver efficiently. Now here we got the solve Sudoku plus puzzle. Now if you want to reset the puzzle for the next user, we will simply click on the reset puzzle button. And here our Sudoku board is cleared now. And that's how Sudoku solver works. By using bitwise operations, the solver can quickly determine which numbers can be placed in any cell, ensuring that the process is efficient and fast. Thanks for watching.